All right, now I did start Screencast-O-Matic before I did the announcements because a few of these may be things that multiple people may be interested in. I'm going to make a guess here. None of you are graduating this term, right? Okay. These two announcements are only for people graduating this term, and the third one's only for people graduating this term. Math team still looking for people to participate. Might be a little ahead of you now, but the more you do it, the better you'll be later when you catch up to that. Okay? This is Courtney, right? He's throwing things at you. Courtney, right? Okay. Okay, I know you're in here. There you are. Okay. And just for your information, I don't know if you'll be looking for me or anything, but tomorrow afternoon from 2 to 3:45, we're scheduled for some training here on campus, the faculty members. So I may be out of the pocket tomorrow afternoon, 2 to 3:45. So if you are looking for me, get me before 2 or after 3:45. I'm going to try to do that training. Now, I think I announced this to you before about the tutoring on both campuses, the hours and when and stuff. So if you need to see that, I've got that information up here. The Space Center, very small tutoring hours for this campus. The SSS is great tutoring hours down here. Birmingham campus, Space Center, really good tutoring hours. I bet you they're the best ones over there because SSS, I think, only does developmental, and the STEM lab, I don't know their schedule. Now, you do know that this is homecoming week, right? Yay, okay, I can tell y'all are enthused. They had a Name That Tune today in the cafeteria. Sorry, I forgot to go by there and do that, okay? I was busy, so I couldn't. But tomorrow, cookout, you got it, okay, a man's stomach, okay, yeah.
I'm in SGA, so.
Oh, I see, okay, so you're involved with it. That'll be on both campuses at 11 o'clock, and I'm sure they'll still have food as late as 12, right? In case people are in class, yeah, okay. So it'll be after 11 o'clock, both campuses. On this campus, I think it's going to be outside the student services.
It's in the gazebo.
Huh?
It's in the gazebo.
Down lower.
Downstairs near the library.
Yeah, okay. It's closer to the library. It's on the library level, and it's but it's downstairs from the student services entrance. Okay, let me get the last two who walked in before I forget. Al is one, and remind me. Hey, got it. Okay, Darren, right? Sure, I'll put you in the right place. Okay, good deal. Okay, so that's tomorrow, and then also tomorrow evening, the Cougar Choice Awards are 5:30 in the afternoon, A.G. Gastineau Auditorium, and that's on the Birmingham East Campus near the dormitory and the nursing building, Ethel Hall building.
Near the gazebo.
What's that?
Near the gazebo over there.
Okay, and they have a gazebo there too, okay. All right, and then on Friday, back to the 90s, Party with a Purpose. And to get in, is this right? You bring a shelter item. That could be a blanket, non-perishable items, that would be food type items, and toiletry items, okay? Anything that would be useful or necessary at a shelter. The party runs from 7 till 9. Leon Kennedy Center, which is a cafeteria level down there in the cafeteria, and that's on the Birmingham West Campus. And then next Monday wraps everything up, and that's the homecoming parade at 4 o'clock in the afternoon. And that gazebo they're talking about there is where?
On the barbecue?
Yeah, it says gazebo to gym. Is that the gazebo on the East Campus?
The East Campus
to the West Campus, okay. All right, that's what I thought it must mean, okay.
Yeah, they're going to close off that road for a second.
What's that?
They're going to close off the road
right.
for a little bit.
And then that's at 4 o'clock in the afternoon. Then at 5:30, the women will be playing Gadsden State. And then do the men play afterwards at 7:30? I don't either. It doesn't list them here, but usually I thought they played tag team. Okay?
It probably is because homecoming. It probably is because homecoming's paired with basketball.
Yeah.
So.
And then the other thing on that, back to the 90s on Friday, that's when you dress up if you want to too, as from the 90s. You can take one of these comedy shows or something like that as you think. But it should be a lot of fun, especially through tomorrow. Okay. Not that that's the most important thing. Okay. And then, just for your information, next Thursday, I've got another meeting at 2 o'clock. Tomorrow I've got one that's a training meeting here in this building. The following one is on the Ethel Hall building on this campus. I'm pretty sure. Let me see. Yeah, okay. And that's going 2 to 5. I just can't wait. Okay. Boy. Okay. Any other people come in since I called roll? All right. And any of you have any questions on anything we've done so far? Now remember, on anytime on a quiz, I won't answer a quiz question. I'll try to clarify a quiz question if you don't know what it's asking for. But I won't do a quiz question, but I will do anything from the book that's similar to a quiz question. But then when you're doing your test, of course, that's a little too late to ask, but I will clarify anything, okay, if I can do so. Okay. No questions? All right, today we're continuing chapter 11. We're just halfway through the chapter. Chapter 11 deals with graphs of linear equations. We're not going to do the inequalities part into variables, okay? And 11.3 is finding, or just the slope of a line. Now, our objectives here is to find the slope of a line given 2 points, okay? Or find the slope of a line given the equation of a line. And then we will use the slope to determine whether 2 lines are parallel, perpendicular, or neither. I think you'll find most of the time they will generally be neither, but a lot of the ones they'll ask you will either be parallel or perpendicular. But any 2 lines generally are neither of those. And this is Joseph, right?
Yes, sir.
Okay. Got to find, there you are. Good deal. And there's Evelyn. All right. And I think I said this on Monday, whatever day it is. Monday as well. Usually they ask for what they call a midterm progress report at midterm. But we were holding all sorts of meetings about retention and stuff like this. And one of the suggestions that came out of that is that it not be a midterm progress report, but just an academic progress report. So since we've had our first 2 quizzes and a test, I thought that was pretty good, data to base on, progress. Well, I'd say maybe a little over half the class turned in the 2 quizzes and took the first test. And a bunch of the others have not either turned in the quizzes or completed the test. So please, folks, if you haven't turned in the quiz, get it to me. And if you haven't taken the test, please arrange with me a time to do so. Now, I'm feeling a little more energetic this week than I did the last 2 weeks. I would have said that more strongly before I walked up the half flight of stairs and went, oh my word, still the hemoglobin's low, the hematocrits are low, red blood cells are low, but I think they're coming back. The good news is, I hope this is good news, no treatment this Friday and no treatment next Friday. So I should get back a little bit of stamina in the next thing. So I should be in my office just about all of my office hours. Now, I could be some late at one afternoon, Like yesterday afternoon, I'll say, I just can't hang. I mean, if I sit there and just sit, I'm not getting anything done, so I may just go home, you know, and try to rest. But I'm feeling today, so far, knock on wood, like I'm going to be able to make it the full length of the day. So after class, if you want to make up something, I should be around. Now, I can stay here in this classroom, or we can find any other classroom that's available. But I won't need, no one else is in this room through 5:15, which is when I normally leave. So please, let's get those caught up. I don't know for sure if you will receive something. I don't remember now who I reported. I think, I know a few of you, since I made that report, have turned in things. So if you did well on that stuff, then you're fine, okay? But, so you might be getting notification from the counseling office or something like that. That's the reason. If I either didn't have a grade for you or the grade was fairly low, then I did report that you might need additional tutoring or, you know, whatever. It's a really lousy little report. They used to have on it, you could put down comments. They took out the comments line, so all I can do is send alert, and that's all I can say on that. Okay, enough of that. So anyway, these are the objectives for section 11.3. Let's go to the first slide. Now, first is find the slope of a line given 2 points. Okay. Someone remind me, what is a slope anyway? Second? All right, a very good definition, a very succinct definition. How much increase in elevation do you have per increase you have in horizontal potential? If you're doing any roofing, which I hope you don't have to do because it's a really hot and tough job you are, okay, you talk about the pitch of a roof, right? And I know you love those chalet-type roofs, don't you, okay, that go a huge rise for a little bit of run. Those are hazardous, okay?
Do you have a harness for the roof?
Yes, you better, okay, or else you're having broken bones, okay? We have a 2-story house. The back part of the house has a really nice pitch, or very shallow pitch, but the other part is a lot steeper. My wife won't even let me up there. She said the insurance money's not worth it, okay? So I'm not allowed up there, and I really don't want to get up there, okay? But on the lower part I can. So that's what we're talking about, rise over run, okay? For instance, other names for it sometimes is grade. When they're building a bridge or roads or something like that, you talk about the grade. How much rise do you have over what kind of horizontal displacement?
They use it in construction too.
Yes, in construction for sure. Okay? Railroad tracks, if you've ever noticed those, they have very little rise over run because those trains can be very long and very, very heavy. Now, how in the world do you get over mountains with that? Say again? Yes, they sometimes go through it and sometimes more than once. Yeah, they will go through this way, turn around and go through this way, turn around and go back through this way, and then start going down the other side and may have to do the same thing there because they don't want very much grade going down either. So yeah, slope is not just some mathematical concept, it's used all over the place. So what if we have 2 non-specific points? And remember, a point in the plane is always an, yes, ordered pair. The horizontal axis, vertical axis. So which of those would be the rise, which would be the run? Vertical would be the rise, horizontal the run. So just because we list x first and y second, this would be one point, x1, y1. Another point, x2, y2. We usually call these point 1 and point 2 so that the indices match up. Then what we would say is the slope is change of y, rise, y2 minus y1, there it is, over, divided by x2 minus x1. Now, does point 2 always have to be to the right of point 1? No, you can pick either one of them to be 2 or either one, and it doesn't matter which one you do. Because guess what? If you reverse these two, you have the same value, but just the opposite sign, right? If you reverse those two, you'd have the same value, just the opposite sign. And positive over positive is positive, negative over negative is negative, positive over negative is negative, negative over positive is negative. So you're not going to change the value of the slope. So it doesn't matter which one you choose to be your y2. But once you choose one to be y2, this one's got to be y1. That one's got to be x2. This one's got to be x1. If you chose this to be the one you did first, y1 minus y2, then you better do x1 minus x2. Keep the order the way it's supposed to be. Okay? Now they're showing it this way, which is usually what we do, but you don't have to do it this way. Just keep them together. Okay? Rise over run. Does that make sense? Okay. Moving along the line from point x1, y1, this point here, to a point x2, y2, this one up here, we see that y changes by this amount. Now that could be doing that. Then the y change would have been negative. It started up here, wound up down there, so y2 minus y1 could have been negative. So whichever. It changes by that many units, so the sign matters here. This is the vertical change called the rise, and similarly, the x changes by wherever you started with here, wherever you wind up there. That's your change of x. The run, okay? The slope is in the ratio of rise to run, okay? Could be positive, could be negative. Could it be 0? Why not? Yeah, it could. Look at most of those buildings over there. In fact, this building, you just can't see it. What's their pitch of their roof? 0. It's no rise, no run. I mean, no rise for lots of run. Because they're flat roofs. That's perfectly fine. That can have a 0 slope. Can you have a 0 run, though? No, you call that a wall, okay? Okay, it's not a roof, okay? Construction, right? Because no change of x when you have a change of y.
They actually do have a small pitch.
What's that?
The state of Alabama
Requires some pitch, okay. But yeah. I think they all have more because those have just got the weak after a while.
12 feet.
What's that?
It's an inch rise for every
12 feet, right. Okay. That's pretty small.
And
I bet you still have some little pockets.
You're not going to notice it.
Yeah, right. Okay.
There has to be some way for rain to run off.
Yeah, yeah. But with that small, I bet you still have places that dip. I don't think anyone can get it perfect.
Nope.
Maybe so. Maybe your company can. Okay. All right. So, how do you find the slope given 2 points? Use the slope formula. Now, why in the world they chose the symbol M, I don't know. But that's what everybody uses for slope. I had a student ask me, maybe mountain? I thought, well, that's as good an excuse as any. But I doubt if that's it, but whatever. The slope M, hang on to that concept, that's just what we name the slope, between any 2 points, x1, y1, and x2, y2, and we'll see in just a second. It's your change of y over your change of x. Rise over run. And that's whichever you choose to be the first point, I don't care. The y for that minus the y for the other one, and then be sure this x is for that first, that goes with that y, minus that x for that. Now, as long as the x's are not the same. Because what would happen if x2 is equal to x1? Say again? No, they don't cancel. Say again? I'd say there'd be an awful lot of slope. If the y's were the same, that would be no slope. That's a 0 slope, that's fine. But if the x's were the same, say again? No, yeah, no run, which means it's all rise. Oh, you don't have to get up. No, okay. No. Watch too many workmen. Okay. What that would be was, if x2 and x1 were the same, what is x2 minus x1? 0. And when can you divide by 0? Never, ever, don't ever even try. So that's why you can have, we call that an infinite slope, which I was saying would be a wall. Because what's the slope of that wall? Huh? No, slope of a flat roof is 0. Because there's no rise over any run. But this would be infinite rise over no run. Okay? Except tell me, is that positive infinity or is it not minus infinity? You can't tell, okay? So no, you don't even go there, okay? So x2 just can't be the same as x1. All right, they skipped example 1. I don't know why, okay? But let's us do example 1. I think I'll just go on and do it on this slide. I was going to look for more white space, but I don't think I'll find any. Okay. All right. Liquid latch on. No, I'm just kidding. I didn't say that. Okay. All right. Let's do example 1. Find the slope of the line in figure 19. That means I have to draw figure 19. Thank you very much. Okay. Let me get my pen set up. All right. This will be my vertical axis, and this will be my horizontal axis. Okay. And we're going to go 6 here, 3 there, 1, 2, 4, 5. Ooh, that's not very even. And we're going up to, well, in my book it goes up to 5 or 6. So let's do a 6 here. That would be 3, and that would be 1, 2, and this would be 4 and 5. Okay? Now the 2 points they give us here in this are point 2, 3. That's your P. And how would I plot 2P? Oh, and by the way, this one's also going down. 1, 2.
Are you doing a problem example 2?
No, example 1. Okay, yeah, that's what I said. They didn't do example 1 on the slide set, so I'm doing example 1 first, then we'll come back and do example 2. Okay? So, I need to plot the point P, and point P is 2, 3. So I want you to help me plot it. How do I plot that point? 2P, 2, 3. Say again? Over meaning right 2, up 3. Okay, just don't say yours. Okay, so there's point P, which is 2, 3. Okay? And then point Q is 6, negative 1. How do I do that one?
Right 6, down 1.
Okay.
Right 6.
Right 6 and down 1. Okay, that would be somewhere about there. This is point Q. 6, negative 1. Okay? Now, the only reason I'm plotting them is because they said in the figure they didn't give us a point, so we had to do that. So, if I were, I'm not even going to, well, I'll try. Okay. Yeah. Say again? Okay. Let's do it that. Let's do the slope. M is equal to, is what?
Y squared or
Y2 minus Y1, X2 minus X1. Now, which you want to be the Y2? I don't care.
top 5.
Say again? What is your Y2?
Oh, P.
3. Okay, that's fine. Choose that to be 3. What does that make you have to use for Y1? Minus a negative 1. Over 6. Oh, If you choose that one to be Y2, that makes this have to be Y1. You can't turn around and make this X2, can you? Wait. Oh, you said it. No, wait.
No. Yeah.
No, you chose this to be Y2. And that to be Y1. You can't turn around and make this X2 because that was your Y2. So you have to use
2.
2. Yes, okay. So you have to keep them in order, okay? Whichever order you choose, you get to choose the order, but you have to make them make sense. Minus 6. Okay? And what's that numerator?
4.
4. Excellent. Over?
4.
Negative 4. And what's 4 divided by negative 4? Negative 1. And sure enough, that looks like a negative 1 slope. Ooh, it's not quite, but it's close, okay? My spacing isn't too good. But what makes it a negative slope? Going downhill left to right, okay? So it better come out negative. If you had gotten those crossed up, you'd have wound up with a positive slope. And you look at that and say, what's wrong with this picture? Okay? And it would be that this picture has a negative slope and you've got a positive. So this is a good check if you have it plotted that sure enough that's a negative slope. And it's about a 1-to-1 slope. It looks like it is. My tick marks aren't in the right place, but otherwise it's fine. Okay. Now, that was example 1. They talk about several things here, and I believe we've done it. Architects using pitch of a roof, stairwells having slopes, grade of a road is a slope, all those kinds of things. Now, they talk a fair amount about these subscripts. The 2 and the 1 really don't mean anything. It just identifies which is point. Y'all chose, when you did this, that would have made this point 2 and that point 1. It doesn't matter which you choose, but once you chose that to be your y2, then you had to have this at point 2. So that had to be your x2 there. They have to match up that way. It didn't matter which one you choose to be 1 or 2. Those are sort of arbitrary. But once you choose 1, the other 3 are fixed. Yes?
What decimal?
I'm sorry?
You saying something about decimal?
I didn't say anything about
You
that.
said something about something point 2 or something point.
Okay, okay, sorry. Okay. I think this may be before you came in. I would have called this, they called this point P, and they called this point Q. I would have called this point P1 and this one P2, meaning 2 different points. Okay. Points on the graph. Like that's the point. Not talking about that one. Yeah. We use those, and we're really sloppy with our terminology. We really should be saying decimal this or decimal that, so people wouldn't get confused like that. Yeah. But we don't. We say point.
When you give it to us, you're going to ask us to find the points and then find the slope. Right?
Okay. No, in this kind of problem, I'll give you 2 points. You calculate the slope.
2 points first?
Say again?
I said you want to tell us to find the 2 points first.
Okay.
And then
I've got to give you some information. A little bit later, I'm going to give you an equation. Then you find 2 points. Okay? So yeah, we'll mix it up all sorts of ways. Yes?
You show us the other equation where it's like, you got to use the long division symbol on it.
Okay. You mean this thing here?
It's like, it's like m equals x, like x1 minus x2, y1 minus y2, and then a long division symbol.
Okay. You mean the 2 points with a line in between?
Yeah. It's
Okay.
all
I don't know if this is what you're asking. You could have written it this way: y2 minus y1 divided by, is that what you meant? x2 minus x1. That would have been legitimate too. Most of the time, I like to put them over each other because, the main reason is this one just came out a whole number. Well, not a whole number, an integer. Fine, you lose the denominator basically. But other times we will have a denominator, and rather than writing it long ways, I like a lot of things. I like horizontal, but this one I like vertical a little better. Okay. So, all right, that's example 1 from the text. Let's look at example 2, and why in the world these are different from the book and the slide set, I don't know. I have not figured that out yet. I'm getting ready to do example 2, which is on page 754. We just did example 1 on 753. Yeah, they're the same edition. Let me make sure the copyright are the same. It's a mystery to me why they're not matching up. It's usually somewhere on this page. Yep, same copyright. I don't know. I guess somebody was doing the book and someone else did the slides. I don't know. Okay. Which you want to do first, one in the book or one on the slide set that's right here? Slide, okay. Find the slope of each line. Notice here they didn't say we have to graph it. So I'm all in favor of not, okay? But we could if you want to. If you need the practice of doing that, we could do that. Or do we just calculate? All right, I'm all with you. So what do we usually call the slope? M. M is equal to what? Y2 minus Y1 over X2 minus X1. And again, it doesn't matter which one you choose to be Y2. Okay, if you want that, it's fine. What I was going to say, you can't choose the first number to be a Y2 because that's not a Y, it's an X, okay? So as long as you choose one of the Y's, it doesn't matter, okay? So you want to choose one. Now the rest of them are fixed. What's going to be minus what?
-2.
A -2, okay? Over 3. You got to have that one because it has to match up with the 1. Minus a -3. And what will this give you? 3 over 6, which is 1 over 2. Now what does that tell you? Okay, you're going up 1 for every 2 you go to the right. So it's a positive slope, but a fairly shallow positive slope. Okay, that's what it's showing. Less than 1. Okay? That would be a steep slope. That would be a fairly shallow slope, but still positive. This would be a shallow negative slope, a steep negative slope. That would be okay. See how that works? All right. So that's all they wanted here. So I'm going to erase my scratch, and we will, if I remember to do that. And let's see what they do. Use the slope formula. Good idea. They, just like you did, -3, -2 be x1, y2, x1, y1, and 3, 1 be x2, y2. They did it just like we did. 1 minus a -2 over 3 minus a -3. That's 1 plus 2. I was going to put this stuff in, but y'all jumped right in. This is 1 minus a minus is plus 2. 3 minus a minus is plus 3. And that would be 3 over 6, which, as you had already noted, is 1/2. There's your slope. And they drew the graph for it. I did arm waving, but there's the actual graph. Make sense? Okay. I want to point something out to you because we're going to use it later. Okay? Here was the point they used as x1, y1. 3 to the left because it's negative. 2 down because that was negative. Okay? Usually we plot that way. Now, notice, and the second point was 3 to the right, positive, and 1 up, that's positive. Okay? But notice here, once you have any one of those points, just any point on the graph, you can go up 1, right 2, and there's another point. Up 1, right 2, there's another point. Up 1, right 2, because it's rise over run. You could go down 2, left 1, oops. I'm sorry, down 1, left 2, and there's another point. Why can you go that way? Because -1 over -2 is still 1/2. So it works whether you go right or left. This would be down 1, left 2. -1 over -2 is still 1/2. And you can do another up 1, right 1, and there's another. So every point on there you can pick out. I usually do that because my lines are so terrible. Not quite lines, you know. So that helps me keep as straight as possible. Does that make sense?
Yes.
All right, good deal. All right, let's back up from that and do the one in the book, example 2. Find the slope of each line. They're going to give us 2 pairs here. Okay, the line passing through -4, 7, and 1, negative 2. Okay? It says find the slope of the line, so all we do is do the slope formula. And what is that? y2 minus y1 over x2 minus x1. And now you get to choose which you want to be y2. Second? You want it to be 7. So we're going to have this being y2. Okay? Perfectly good choice. Nothing wrong with it. What then is going to be your next number? A negative 2 minus a negative 2 over... Yes, once you chose that to be y2, this one has to be x2 minus 4 minus 1. Okay? What does that give you in your numerator? 9. In your denominator? Negative 5. So that's going to be a negative 9/5 slope. What does that mean? Give me two things that you could observe from that. It's going downhill, you're right. Okay, down 9 for right 5. That's a fairly steep slope. That would be 1.8, negative 1.8. Almost negative 2. So it's a pretty steep slope downward. If you had chosen your y2 to have been negative 2, that would have been negative 2 minus 7. That would have been minus 9 over 1 minus or minus 4, which would be 1 plus 4, which is 5. You have to still be negative 9/5. Doesn't matter which one you choose, but once you choose one, the rest of them are fixed. Okay? And if you look in the book, you'll see that's a fairly steep slope. Okay? Down 9 for every 5 to the right. Or up 9 for every 5 to the left. Okay? That would work too. All right, let's do the next one. The line passing through negative 9, negative 2 has 1 point. The other point is 12.5. Okay, what would be the slope of that line? I can't hear. Okay, my hearing's so bad. I hear you saying something, I can't make it out.
The first set of coordinates is the first set of coordinates, the other coordinates, the second part is the first.
Okay. My hearing is so bad. A little bit louder?
So 5 is...
Okay, you want to start with 5?
Yeah.
Okay, 5 minus negative 2. Is that what you were saying? I'm so hard of hearing. Okay. Once you've chosen, you just got to choose a y first. I don't care which one of the y's. He chose a 5. Perfect. That makes the y1 the other y, okay? Minus a negative 2 and 12. That makes the x2 have to be that one that goes with the 5 minus a negative 9. And what does that give you for your numerator? 7 over 21. Which is 1 over 3 slope. What does that tell you about the slope? Say again? It's rising, but not very great. It's a pretty shallow slope, less than 1, but it is a positive slope. Perfect. Okay? All right. Does this make sense? Now, you're not going to need this in this course, but in future courses you might. There is a little terminology we use here. What's the minus sign there? That's a subtraction. What's the result of a subtraction equation? Second? The result of a subtraction equation that has a name. No, that's multiplication. Second? Quotient is division. Sum is addition.
It's
difference. All right, it's a difference. Okay. All right. Did someone say that at the beginning? Okay, I'm sorry, I can't hear. You have to speak up here. Okay. I hear wrong answers much louder than I hear right answers. Okay? So you have to speak up. Okay. We call it a difference. Okay. Okay. Now, in the Greek alphabet, the letter for D is a delta. I don't know if y'all know your... Yeah, okay, the delta, okay? My sister-in-law was a tri-delt, delta, delta, delta. I also had a niece who was that, and she said they had to answer the phone when they were the freshmen, what do they call it, pledges. They had to answer the phone. They say, delta, 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 can I help you, help you, help you? Yeah, really don't. Okay, but anyway, so they'll call this delta y, the difference in y's, over the difference in x's. Delta y over delta x. You'll see that. Say again? Yes. Okay. Yeah. You're talking physics, basically. Very good. Change of something is also called a difference. Okay, and the difference is delta. And I hope some of you make it all the way to calculus, and then we'll take a limit of those deltas, and you'll call them dy dx. dy change of this, change of that. And actually, probably not in this course, but in the next course you take, we'll have another name for this, calling it a difference quotient. And they'll act like it's something brand new. And it won't be. It'll be just a slope. This very thing you've been doing before. And that's a slope. So this isn't just something they made up for 098. You'll see this the rest of your mathematical career. However far you go, you'll run into this kind of thing. It's pretty neat stuff. And the book actually got theirs right too, by the way. I forgot to tell you. Negative 9/5 for the A part and 1/3 for the B part. All right. Okay. Oh, I didn't click through all these slides because I wasn't sure they were going to do all this. Okay, let's go back a little bit. I stopped right here and said, yeah, there's the graph, and I went on from there. Well, after they do the graph, then they put the number, the points in there. -3, -2, I would have done that first. And 3, 1, that's the second one. Now, this is the one we did in the book, not the one, the slide set. And then they showed you the run was 6. You can do this too. It's not recommended, but 1, 2, 3, 4, 5, 6. There's your run, okay? That's what your difference is. Difference of sign numbers gives you exactly that. And your rise, I would have done that first. That's your 3. Yeah, count that. 1, 2, 3. Yeah, there's your rise over run. 3 minus a minus 2, sure enough, is 1 minus a minus 2, sure enough, is 3. And 3 minus a minus 6 is 1. So that's what you're doing. You're counting those number of things. But you remember, have I told you this? I think I have. That basically, to be good in math, you have to be a little lazy because you're always trying to find the quickest way of doing things. And in the old days, probably somewhere way back there, when they were doing this, they had to count how many blocks here and count how many blocks there. So much easier to subtract sign numbers. Once you know those rules, done. You know, you don't have to count blocks, or pebbles or whatever. Okay. So, they did a B part here too. Let's do the B one here. We can do it pretty quickly. What is your slope here? Oh, yeah. 4. Okay, good start. Minus a -2. -1 minus 1. And that would be 6 over. Height. No, what? -2. Which is -3. What does that tell you about that slope? Going downhill pretty fast. Not quite like that, but pretty fast downhill. Okay. Yeah. Okay. So let's see what else they do for it. All right. They use the slope formula. Good for them. We didn't write down which was which. I already erased mine, but we just got the same answer, -6 over 2, which is -3. Yes, okay. Then they drew the slope and put the points in at the same time. Good for them. And you see that is a really steep slope downhill as you go left to right. Okay. And by the way, when we're talking about this, never say, well, when you're going from right to left, that's an uphill slope. No, don't do that. Always go smaller number to larger number on the x. That tells you what your y. Rise is always going from left to right, not right to left. Okay. Okay, your rise is -6, which means it's actually a fall, not a rise, and your run is +2, which -6 over 2 is that. Okay. Now, caution.
Caution.
I'm not seeing this in the book, but I guess it must be there somewhere. We've already said this, haven't we? Makes no difference which point you make x1, y1, and x2, y2. I've already told you this. However, be consistent. Start with the x and the y values of one point, either one, don't care, okay? Subtract the corresponding values of the other point. So if you start with this one, then it's y1 minus y2 over x2 minus x1 minus x2. It doesn't matter. It doesn't have to have the same subscript. It doesn't have to be bigger minus smaller. You just have to keep them in order. We've already said that. That's our caution. Let's throw caution to the wind. No, okay. Say again? Yeah, you'll get the same answer both ways. Right? Because you change signs both top and bottom, and that gives you the same result. Positive over positive is positive, negative over negative is positive. Negative over positive is negative, and positive over negative is negative. Yeah, so you get the same value. What's that?
On the test, the numbers will be the same no matter what.
Yeah. As long as you do it right, the numbers should be right. Okay. Now, positive and negative slopes, we've already been talking about this. A line with a positive slope rises or slants up from left to right. Remember I said don't go right to left. Do left to right. It's going upward. A line with a negative slope is falling, meaning slanting downward as it goes from right. Left to right. Remember, always go left to right. Okay. Here's example 3 on the slide set. Find the slope of each line. All right. We've not done any like this, have we? Okay, let's do. M is equal to 2 minus what? How'd you get that? Yeah, but which is your y? Okay, what did you say? 2 minus 2. Okay, I'm sorry. I thought I heard 4. Over 4 minus a negative 4. And what does that give you? 0 over 8. It really doesn't matter what it's over. It just can't be 0. What kind of slope you have there? Say again? It can't be 1. It have to be 8 over 8 to be 1. So that's going to be 0. If you have no rise, which you didn't, it's 2 here and it's 2 there. They're the same y values. So you have no slope between those two x values. Okay? That's a 0 slope. Huh? Yeah, all lines are straight lines. Horizontal line. I knew that's what you meant. Okay. Horizontal line. Okay. All right. Now, I think they're going to actually do it for me, so I don't have to. So let me erase this, and let's see what they do. Yes, they got 0 over 8, which is 0 over 8 is 0. There's your slope, and there's the points on that line. Okay. Now, I'm going to ask you a question I don't think they're going to ask. What's the equation of that line? What does every equation always have to have? An equal sign. Very good. So you better have something with an equal sign in it. Y is equal to 2. Okay? Because everywhere on that line, the y value is 2. There is no x anywhere in there because x, you can change it anywhere you want to. It doesn't make any difference. Y is equal to 2. The horizontal lines are always written as y equal k. Whatever the k is, in this case, it was 2. Remember that from before? Okay. All right. Your run is 8. But what's your rise? You have no rise. Your biscuits didn't rise this one. No, they're flat as a pancake. Okay, so that rise is 0. So the slope is 0. No, it's a horizontal line. Straight, sure, but horizontal is the better word for it. Okay, let's do example 3 from the book. From the book. Let me get this off of here. And the one from the book is find the slope of the line passing through the point -5, 4, I can't write, okay, and 2, 4. What's the slope of that between those 2 points? 4 minus 4 over 2 minus a -5, and that would be 0 over 7, which is 0. Anytime you have a 0 in the numerator, as long as you have something not 0 in the denominator, you have 0 as your answer. Okay? What does that tell you? Horizontal line. It's neither going up nor down, so it's neither a positive slope or a negative slope. It's no slope, a 0 slope. And what's the equation for that line? Y is equal to 4. It's 4 there, it's 4 there, it's 4 everywhere. Okay, got it. All right, that was no extra charge. It wasn't in the book. Okay, so that's example 3. Now let's move on to example 4. And they did graph it, I think, in the book, and you can see it there. Your rise was 0, and your run was, what was that, 7, yeah. All right. Example 4. Let's do the one in the slide set first. Find the slope of this line. Oh, okay. What would that be? M is equal to 4 minus 1 over 3 minus a -3. And that would be 3 over. Do y'all hear sirens going off?
It's the
No, I'm just kidding. I'm saying, warning, warning, warning you. Guess what? You can't ever do that. Divide by 0. You can never divide by 0. Those are the warnings I was talking about. Okay. Sorry. Okay. I was being stupid. Okay. You should get used to that by now. Okay. You have a rise of 3 for what run? 0. That's what we call an undefined slope. There is no definition for it. It's going vertically upward. So guess what line it is? A vertical line. Okay? Now, my next question for you, you should have guessed it already. What's the equation for that line? Yes, x equal -3. Because, see, if x is -3 here, see, it's -3 there. If every point's on that line, it's going to be -3 everywhere. Over here. Okay. So, yeah. You don't need to know that yet, but we've already done that. Okay. So, let's see how they proceed with theirs. Is this making sense?
Yes.
Okay. So, they did 4 minus 1, just like we did, over -3 minus a -3, which is 4 minus 1 is 3, over -3 plus 3 is, oops, 0. Can't do it. Undefined slope. That's what UNDEF means. Undefined slope. Okay? And there's the graph of it. And they didn't give you the equation for it, but x is -3. Everywhere on that line is a vertical line, undefined slope. Because you can't tell me whether that's rising or falling, okay? It's undefined, okay? So, what's that?
Press it one more time.
Do what one more time?
Press the thing
Oh, you think there's something else on here. Well, I would have thought so too.
One more.
There we go. Rise of 3 and
0.
run of 0. There is no change. That's a vertical line. With the equation, x equal -3. Very good. Okay. All right. That was example 4. All right. So, sort of to summarize those last 2 or 3 or 4 or whatever we did. Slopes of horizontal and vertical lines is horizontal lines which have equations of the form y is equal to k. You read it before I could cover it. Have a slope of 0 because there's no rise because the y is the same with any kind of run. Okay? Okay? But vertical lines, on the other hand, have a form of x equal k, which have an undefined slope because you can have any kind of rise but always 0 run. And you can never, ever divide by 0. Yes? K is just a number, any number you want to choose. -3, 15, 4/3 pi, you know, whatever number you want it to be. But it never changes. Why is it never changing? It can be here, or here, or here, or anywhere there. Just any constant, or x, any constant. You know, where it is, that would be your vertical. Make sense? Good question. Okay. Now, what if they give you an equation for a line? Not 2 points, an equation for a line. Can you find the slope from that? Sure. The answer is yeah. How? Okay? Here's the 2 simple steps. First, solve the equation for y. In other words, you have x's and y's and numbers all over the thing here. But if it's an equation, what also must you have? Equal sign. So you have numbers, variables, and equal sign, numbers, variables. Okay? So get all the y's on this side, all the x's, and all the just pure numbers on that side. Okay? With the equal sign in between. Okay? That means adding or subtracting terms first. Okay? Then maybe multiplying or dividing next, so you get a naked y here. Okay? That's all you got, just a y. Okay? Then, the slope is given by the coefficient of x. Whatever the coefficient. Who cares about that last, the number term? The coefficient, the thing that goes in front of the x, that's your slope. Without plotting a single point, you can get the slope of a line. Okay? Let's do one. Find the slope of that line. What would you do first? Okay, subtract 5x from both sides. That's a perfectly legitimate move. Okay, and this adds to 0. What does that give you? Negative 6y is equal to negative 5x plus 2. Okay? Now, I chose to write it that way for a reason. You could have written 2 minus 5x, just as good. Yes?
Isn't that just a symbol for subtraction of the 6 actually?
Okay, I can't hear.
Isn't that symbol just a symbol for subtracting those instead of actually making negative?
Okay.
It wouldn't have a negative symbol, it's just 6y.
Okay, say that one more time. Oh, this right here?
He basically
Okay,
said-
I got you. Okay. I was saying negative, and you could have been saying subtraction or vice versa. Okay? They mean the same thing. If they're in between 2 entities, that obviously means subtraction. If it doesn't have an entity on the left-hand side, then it makes it just a negative. So, again, we're a little sloppy with our language sometimes, but math is very precise. So you just have to keep in mind. Now, what do we do next? Oh yeah, we don't have a naked y there. We just have something else with the y. So how we undo that is divide by negative 6. But if you divide it on one side, you better divide it on everything on both sides. Okay? What do you have left on the left-hand side?
Y.
Just a y. Okay, just what you're looking for. On the right-hand side, what do you have?
5/6x.
Second, 5 over 6 times x minus 1/3. Now, if all you're looking for is the slope, what is it? Which is? The coefficient for x. 5 over 6. 5, 6. Okay? Meaning it's rising 5 for every 6 across it goes across. So that means it's a positive slope, not quite a 1-to-1 slope, but close to it. That's what that means. Without plotting a single point, you know what it is. Now, for those who are interested, what's that negative 1/3 out there? Has nothing to do with the slope, by the way. What is the negative 1/3? The what? It's the, okay, a point has to have two values. Okay? But it's called a, anyone know? You don't have to know this yet. We're going to hit it later. Anyone happen to know what it is? It's called the y-intercept. Okay? And here's how you know it's a y-intercept. Remember we did the intercepts? How do you get a y-intercept? Say again? Okay. Set x equals 0. Let's not get rid of it, just to make it equal 0. Okay? So, if you make x equals 0, this term becomes 0, and then what you have? Y is equal to 1/3. So the point there would be 0, 1, negative 1/3. So yeah, that's the point on the y-axis, down 1/3. It's the y-intercept. Okay? We don't need to know that yet. All we're dealing now is the slope. How you get this, solve for y, the coefficient of x is the slope. Done. Period. That's all you have to do. Pretty straightforward. Okay? So let me erase my chicken scratch here, and let's see what they do. Oh, guess what? They subtract 5x from both sides. Good for them. Okay? And that gives them a negative 6y, okay, is equal to negative 5x plus 2. And then what? Negative 6. Excellent. Divide every term on both sides by negative 6. Got to do the same thing on both sides. Okay? And that gives you y is equal to negative over negative is positive. Yes? Yeah, and then this form right here is y is equal to mx plus b. Or your plus now is minus. Or your b is a negative 1/3. Yeah, that's exactly it. And the m is what? Slope. So you see, they use the right name for it too. And there we have it. All we're looking for here is the slope, but also your b is the y-intercept. What's that?
How do we get the 1/3? How do we get that 1/3?
Oh, right here. Okay, now first, let's deal with the signs. Plus divided by negative is minus, okay? And then 2 divided by 6, well, they won't divide by 6, but 2 will go into 2 how many times?
1 time.
And 2 will go into 6? 3 times. That's how you do it.
Thank
Okay?
you. Thank
Yeah,
you.
good question. Excellent question. They just sort of slid past it, and I did too. I've been watching the Olympics, the sliders, you know, never mind. Okay. All right, good deal. Now, let's see. The slope is 5, 6, which is the coefficient of your x term. Okay. Now, before we move there, let's go back and do the one in the book. Example 5. Okay, they actually have 2 of them. No, they have 3 of them. Okay? So, let's do, the first one they do, 2x minus 5y is equal to 4. Oh, we're all right here. 2x minus 5y is equal to 4. How would you find the slope of that line? Say again? Add 5y to both sides? You can do that. It's a legal move. Okay. What does that give you? 2x is equal to 4 plus 5y. Is that what you said? Okay, that's true. And what? Oh, yeah, subtract 4. Okay. I was wondering where he was taking me there. Okay. All right. That's a legal move in most states, so that would be 2x minus 4 is equal to, that adds a 0, 5y. Next, divide both sides, everything on both sides, by 5. Okay, and what does that give you? Y is equal to, okay, let's write the other first. 2 over 5. 2/5 x minus 4/5. Now, why am I picky about that? I usually say you can do anything wrong. Yeah, because we like this, and what Greg Troy was saying, mx plus b. That's how they like to do it. So that's what we're heading for. So the question is, what's the slope of that line? 2/5. That's all really they were looking for. Okay, there's the slope. Okay, yes? I'm sorry? I can't hear you. Homework?
He has to go.
Oh, you have to go a little early. Okay, I see. I was going to say, not that time yet. Okay. It's going to be the, remember these have all the answers in the back, so do some of the problems. I would definitely do all of 4. There's 4 parts there. Do some of the problems, you choose how many, 5 through 8. Basically any of them there, but when there are groups of them, any of them 11 through 16. Any of 17 through 20. Any of 23 through 36, and any of 37 through 50. Okay, we'll do if we get to the others, listen on YouTube and you'll see whether we got any further. Huh? Oh, that's on pages 760, 761, 762. 760 to 762. Okay? So is that what you needed? Okay, let's do from the book 5B. Okay? So let me get this cleared. And 5B will be, oh my goodness, wait a minute. I think they left something out here. Okay, now I see what they've done. The B part is 8x plus 4y is equal to 1. 8x plus 4y is equal to 1. Now, by the way, if you noticed, Joseph decided to move things around and he took a couple more steps, but still came out very legal. Didn't do it the same way they did in the book, but they got the same slope, 2/5. So what you want to do on this one?
Minus 8x.
Okay, we're going to subtract 8x from both sides. And what will that give us? 4y is equal to?
1 minus 8x.
Okay, there you're doing it again, aren't you? Let's put it in, negative 8x plus y. Plus 1, not y, goodness gracious. Where did that come from? Who did that, huh? Okay, plus 1. I can't get my pen to work. There it is. Okay, I can't get my head to work. Now, not what? Divide by 4. Everything on both sides by 4. And what does that give us? Y is equal to? Negative 2x plus 1/4. Very good. What's your slope? Negative 2. All right, they did it really well. Okay, let's do the C one. 3y plus x is equal to negative 3. And what would you do next? Say again? Oh, I forgot to write it in, didn't I? Okay. I said it, but didn't write it. Is equal to negative 3. That wasn't an equation until you put that in there. Say again? Subtract x from both sides, and that gives us 3y equal to negative x minus 3. And now what? Divide everything on both sides by 3, and by 3. And that gives us y is equal to negative 1/3 x. Second? Minus 1. And what's your slope? Negative 1/3. That one's going downhill. This one's going downhill steeper. The first one we did was going uphill, not too steep. 2/5 was the slope. Good deal. And remember, folks, Every one of these examples in the book is followed in the margin by more examples. Those are the best things to do as soon as you can get out of class, and have time here at home or wherever, do them as much as you can. Okay? The next thing we get to, which I'm afraid we don't have time for today, but let's just check. Yeah. Okay? Let's do just a little bit of preparation for it. And that's this. What do we mean by parallel lines? Did y'all hear what the assignment was before when I was giving it to Greg Joy? Do I need to give it again?
Yes.
You do want it again?
One more time.
Okay. All right. Well, then we probably won't have time to do much on that. Okay, the assignment then, we'll start next time with, on page 758, with that objective 3. So here's your homework assignment again. They have concept checks in here. Please do those. Those are pretty good. We'll do some of these in class. That's why I didn't say them for Greg Joy. But number 4 has 4 points in it, even though it's a concept check. I would definitely do those 4. They're all in number 4. Then do any of the problems 5 through 8. There's a couple more concept checks. Do any of the problems 11 through 16. There's a couple concept checks 17 and 18. No, 17 through 20. Do them all. There's downhill skiers. I saw that last night. Okay. A couple more concept checks. Then you have any of the problems 23 to 36. Any of the problems 37 to 50. And we'll stop there and do the rest of those next time. Okay? And that took me to time. All right. Good deal. Any questions? What's that? You want to do it now?
No,
tomorrow. Okay. What time tomorrow? After 11? Huh?
You say your class was at 10:45?
My class gets through at 10:45.
Okay.
Okay. Now I'll be up here for a few minutes after 10:45. Then I'll go to my office. Okay. So if you come by here, if I'm still here, you can do it here. Or if I've gone down to my office 265, you can catch me there. All right. Good deal. Thanks.
And so do you be on Fridays?
I'm usually on the Birmingham campus on Fridays.
Okay.
Are you? Is that inconvenient?
Well, I'm not in class
Oh, good
at
deal.
all on
Thank you.
Friday, but,
You're what?
what time, I don't have class on Fridays, but what
Right.
time do you usually be on the Birmingham campus?
I'm usually there 7:45 until 11:45. Now, let me warn you with this. They love calling meetings on Friday. I don't think we'll have one this Friday because the dean's aunt died and she's going to be leaving tomorrow to fly up there. Or maybe she's leaving Friday to fly up there. But anyway, it's in Maryland. So so I'm pretty sure we don't have a meeting on Friday, this Friday.
Okay.
But in general on Fridays, they love having meetings. If I have an excuse to get out of it, I'd love to have it. No, I'm just kidding. Okay. So.
I was gonna say that, because I have class, I was thinking of Monday then after class, but, so right now, after class, what kind of time frame, do you work with? Like,
Okay, most of the time, as long as I'm feeling okay. I'm here from 3:15 to 5:15.
Okay.
Okay, so I'm here till 5:15. Most days I can stay even after that. But if some of these days I'm just completely beat, I might leave early. But unless you mind, you could be taking the test and I'll fall asleep up here. I'm fine with that too.
Well,
Okay.
I actually have a micro. My micro is on Birmingham campus, so I was.
Oh, right after this class?
Yes, well, it's about an hour.
Oh,
and some after.
Yeah.
I have about an hour or so.
Yeah.
A little bit.
Yeah, well,
I'll
you're
try
certainly
for
welcome to.
Monday then,
Okay.
after.
That first quiz has to be turned in as well. The one
You know, I told you that one would be optional. So if you just want to go with the second quiz. Now, I'll tell you this: most people, not everybody, has scored better on the first quiz than they did on the second. And I would have sworn it had been the other way around.
See my grade rate of 94 on the take home, not
Yeah.
the first one, but the second.
Right. Okay. So if you're happy with that, you can go with it. If you think you can do better, do them both. I'll throw them both in there. I'll do whatever makes it best.
Okay. Thank you, Dr.
All right. Glad to.
Thank you.
Absolutely.